How did you know I was topping off my coffee, Mo?
I could sense it, Dave. Or maybe because that's what's on my mind right now.
Doing a sound check. Can you hear me?
Loud and clear.
All right, great. I have to join audio on my phone. So.
Oh, I'm glad that worked out. Let's give it 45 seconds more, Louise, and then you can take it over.
All right. Do you see the slides or the presenter view?
We see the slides.
Okay, that's great.
We do not see any notes for the presenter. All right, it looks like we've reached equilibrium. Folks have rejoined. In the second half of the session today, we'll have an overview of Dockstore, Picture, Seven Bridges, and ISB CGC. And up now is Louise from Dockstore. It's all yours, Louise.
All right. Hi, everyone. My name is Louise. I'm from the UC Santa Cruz Genomics Institute, where I'm a software engineer on Dockstore. So today I'll be giving kind of a mix-up between an end-user overview of Dockstore plus some interoperability highlights for developers. For time, I've cut out the live demos here, but tomorrow Beth will be largely covering the same content during her presentation of use cases. All right, so what is Dockstore? Let me first give you the full description. So Dockstore is an open source platform for sharing scientific tools and workflows. It's a registry of Docker-based resources described using descriptor languages such as CWL, WDL, and Xflow. And our goals are to increase the portability, interoperability, and reproducibility of research in the sciences. So for portability, that means workflows should run in any environment that supports Docker. And for interoperability, we use the G4GH standards to support multiple integrations so that users can use their preferred compute and data storage environment. But most importantly, for reproducibility, Dockstore is a place for researchers and developers to come together and share their work so that others can use it. And this is done using a combination of containers and workflow languages that minimizes redundant and error-prone installation of software, and also increases the transparency of what methods were actually used in analysis, which allows other researchers to then verify the results and apply existing methods into their own research. But in simple terms, what is Dockstore? You can think of it as an app store for bioinformatics. So how is Dockstore useful and what problems does it solve? We can go with the first and the simplest use case is to solve problems relating to search and findability. For example, a researcher might want to do some type of genomics work, some assembly, alignment, variant calling, or entire genome-wide association study, but they want to know what software can be used for the job, what works with their data, where do they download that software, what version, etc. That brings us to Dockstore's function as a centralized registry and a centralized catalog of bioinformatics tools and workflows. So the way this works is Dockstore, through its integrations and connections with other APIs, brings in content from a variety of sources like GitHub, Bitbucket, Quay, Docker Hub, or content can be also hosted directly on Dockstore so that all the resources come together to be a centralized hub and to create a better user experience and shared functionality. We also connect now with Zenodo, so you can create digital object identifiers for your content and link those DOIs directly to your publication. So in terms of our search interface, you can search for workflows by author, organization, descriptor type, etc., and use facets for filtering or use advanced search to have more parameterized functions. To navigate to the search bar, it's on our search toolbar. For example, you can search for things like GATK workflows. Quite a few entries will pop up, and then you can filter by the name, what platforms they're verified to run under, authors, etc. We also have organizations and collections. So an organizations page is kind of a landing page for labs, collaborators, groups, consortia to collaborate and showcase their work. For example, they can create collections of the specific workflows they're using for a project or grant, et cetera, to make sure that researchers that are working on a project together are using the proper software versions to make sure everyone's aligned. For these organization and landing pages, there's permission-based roles for members of the organization. So you can control who has access to editing the page, who has access to adding others, and to who can create and add to existing collections. So the most common use case for a user to want to use Dockstore is to simplify the installation process. So this is the case where a researcher already knows what software they want to use, but they're running into installation problems when trying to get that software onto their system. That could arise from multiple issues, such as the software was built on a different operating system, in which the executable files won't run on their system, or other problems related to like compiler or build issues. It can also solve a bunch of dependency mismatch problems. For example, you might need one version of, say, Python or Java for some of your applications, but you need a different version for another. So, or if multiple tools need the same dependency, but different versions of that dependency. So how this works in particular is how Dockstore packages its content. So Dockstore solves that installation and dependency problem through its usage of containers, specifically Docker containers, and using descriptor languages to actually describe the steps of the workflow and detailing what parameters are needed, etc. I'll go into more details about what containers descriptors are in my later slides, but the main takeaway here is that by packaging all the software into containers, which will include all the dependencies, the operating system, and the software itself for, say, something like BWA MEM, and then just like decoupling how to run each step of that pipeline in a descriptor language, it makes it really simple for, say, someone to move their analysis in a portable way from cloud to cloud, from VM to VM, basically from different types of compute environments, while also maintaining that your workflow, your results are actually reproducible, and the same data inputs and the data inputs will generate the same outputs regardless of the system that you're using it in. So I'll go more into some details about containers, descriptors, and parameter files. First, like what exactly is a container? A container is a package of code with all its dependencies. So this is, for example, what do you need to run something like BWA-mem? You need the tool software. You need to install any dependencies that might be needed to compile the tools, etc. And the operating system that it runs in, like what flavor of Linux, what flavor of Ubuntu has this tool been built upon, and the dependencies relied upon. For a descriptor, the descriptor is basically the workflow language used to describe how to run your workflow or pipeline in an abstract way. So by abstract, I mean it's parameterized to say which I need specific types of files. I need a BAM file, I need a FASTQ file, etc. I need this. I need containers. I need to run tasks, and defining those tasks, or what steps are in this task and when to run these steps, or to define the parameters needed for computational resources, like what type, how much RAM do I need, how many cores, etc. And in descriptor, you can also add in metadata that includes information like authorship or contact information. And the different descriptor languages have more of nuance on what they can include in metadata than others. And what brings this all together is the parameter files that are also registered on the tools and workflows that are on Dockstore. So in a parameter file, you will actually specify what the actual input and output files are. For example, on your local machine, you'll give them the path to the FASTQ file on what directory it's in, or using file provisioning plugins that might be available, whose availability might be variable depending on your compute environment or analysis environment that you choose, so that files can be grabbed from, say, cloud storage environments like S3, Google Cloud, etc. So I'll dive in a bit on what these actually look like in like a simple example. So like I said before, containers are built from Docker files, which describe the packaged up environment. Here you see the base image that this container will build upon. It's an Ubuntu image, so you can select what base operating system is in this. It's going to be building off this container and where you're going to install your tools on. And then you'll basically describe what dependencies need to be available in this environment for your software to run. In your Docker files, you'll also be able to describe like what instructions and commands will be needed to run to set up the environment. You could grab scripts or grab even the source code from a GitHub directory and build this environment pretty much so that it's ready to go and can support your analysis regardless of what is actually available on your machine. So this is just, these examples I'm showing now are just more for like conceptual understanding. We have plenty of documentation that will go into available that will go into how to actually create Docker files, descriptors, parameter files, etc. This is more like just to give a conceptual understanding of how these three things come together. So here's another example. This time, this is for a snippet of a WDL descriptor. So in this snippet, I'm just basically describing a single task. This task is describing, for example, it needs a file, a FASTQ file, an input like disk size or threads, etc., and is also describing what command will actually be given in the environment to set off this task, and what compute resources are required for this task. And so the parameter file, like I mentioned, brings it all together. See, right here, it's actually giving the actual input read file that's located, in this instance, on an S3 bucket. The file provisioning plugins that are available on the analysis environment that this workflow is actually going to be run will then grab grab and download this file from the S3 bucket and provision it at runtime to the workflow. You can also specify and parameterize your compute values, and depending on whether your analysis environment supports these values are usually used when creating compute instances on the cloud and how to initialize those instances with specific resources. So once you have all those pieces together to register your workflow, your tool onto Dockstore, there's various ways you can register content into Dockstore. This is just more of a high-level diagram. I won't go into too many details just because it can get a little complex depending on how you want to get your content into Dockstore. But basically it goes down to you can either host things completely externally via GitHub, via putting your descriptors or Docker files onto GitHub, Bitbucket, GitLab, etc. And then and then that will be able, if you use Quay as your image registry, then it'll be able to detect any changes on your source control, from your source control repos, and continuously build new Docker images for you then to pull into your analysis environment so that these images are up to date based on any changes that are happening and that you push to your external hosting repository. On Dockstore itself right now, you can host the descriptors on Dockstore. We still do not support hosting containers or images on Dockstore directly. So if you do host your descriptor and parameter files on Dockstore, you will have to point to an externally hosted externally hosted image of your container from Quay or Docker Hub. So this all ties together because by putting these systems together in these building blocks, that allows users to tackle more complex use cases and bring collaborations to scale. So for example, if a team of collaborators from 8 different institutions need to work together on a study that analyzes genomes of thousands of individuals, this is the building blocks that I've described actually allows for that to happen. Each institution might be using different compute environment for analysis that can involve different workstations, local machines, or on-site servers, or they could be using various cloud platforms and they're only allowed to have data stored on specific cloud environments, or not even, or they have to have data stored locally, depending on some restrictions. By separating out these concerns and allowing people to bring in their specific compute environments, we can essentially bring analysis. We can export the analysis to where the data is. And so also by making sure that the software is containerized and the scripts are robust and parameterized, it can make sure that the data is more designed to work to circumvent the problems that might happen where data might be where the tools might be designed to work at one institution and then you find that they don't work at another. So that brings us to why the interoperable cloud ecosystem is connected to Dockstore. Basically, the content on Dockstore can be exported to the execution environments like Terra, like the 7 Bridges Cancer Genomics Cloud, or providers such as DNA Stack or DNA Nexus. And this is done through the GA4GH standard APIs, which allow Dockstore to connect to the variety of cloud environments and pretty much bring analysis to the analysis algorithms to the environment, rather than pushing around data in what might be a less secure way. So right here is a screenshot of pretty much what a workflow looks like on Dockstore. As you can see, there's some launch with buttons that will export these workflows or import them into an environment, analysis environment. What's not shown here is the new launch with buttons that we've released for Biodata Catalyst and Anvil specifically, so that the workflows can be exported to like the specific environments related to those two collaborations, which might have different data controls or different user access controls for those cases. So this is just a quick overview of how it looks like once you once you click one of these buttons to say, I want to export this workflow to Terra, you'll be redirected into the Terra interface. This is assuming you're logged in. If not, you'll be prompted to log in. You'll see the workflow that's coming from Dockstore here on the left, and then you'll be able to select which workspace in your Terra environment that you want to download it to. And here, instead of uploading or having a different parameter file that you use, you can actually fill in the attributes of the workflow directly on the Terra environment, or you can upload that JSON that's provided on the Dockstore site to fill in these values. As you can see here, instead of in the example that I had where the files were coming from an S3 bucket, these files are actually coming from a Google bucket, so those will be provisioned into the instance that is spawned when you click the Run Analysis button. And basically, this is just a screenshot of showing that workflow had ran through. It succeeded. Geraldine went through and showed how you can see the different timing diagrams, etc., after the workflow is completed. We also have a Dockstore CLI, and this is more of a handy developer tool, so that before you set off a workflow run on an execution environment or on a cloud instance that might accrue costs, or if you are working on a local machine, that you'll be able to still use the Dockstore, the content that's available on Dockstore to launch workflows. We do have some of our own file provisioning plugins provided so that you can still grab files from S3 buckets, Google buckets, etc. And pretty much this is more designed when you're working with small test sets, snippets, that we encourage content creators on Dockstore to provide to users so that they can kind of mock and see if the workflow works as expected or will work with their data. So there's some other Dockstore features that I've cut out due to time, but some things we've been working on to enhance and support is our base like Dockstore language descriptor file support on the site. Currently, we support CWL, WDL, and Nextflow. things like syntax highlighting so on the site you can see the important parts of each, like highlighting what a task, what is an input file, etc., and validation. So we support various versions of the descriptor languages available on the site, and we will actually go in and when a descriptor file is attached and registered onto Dockstore, we'll actually go in and depending on the version, say that this is a valid WDL, this is a valid CWL file. And there's also some DAG visualization available for the content on Dockstore, so you can see visually what steps are on the pipeline in the descriptor. Recently, we've added the ability to snapshot and request DOIs for the content on Dockstore. A snapshot is basically when you freeze the workflow version of your workflow so that it's immutable. It's mostly immutable. You can change some metadata characteristics, but generally the things like the descriptor and the parameter files are locked down. So then once you have snapshotted and frozen your workflow version, you can request a digital object identifier for your workflow, and that is done via Zenodo, and you then can use this as a publication reference, so that this is a big factor in the reproducibility aspect, so that when things are ready for publication level, you can refer to a version that is frozen so that it'll be unchanging and people will be able to run your workflow as it was for publication. And right now we have a public release of our apps and services. So instead of just launching workflows from Dockstore, you'll be able to launch more fully formed applications and services such as a DICOM viewer, looking to see how this will work, or even full genome browsers, etc. So that functionality is now live on Dockstore, but it's still a changing and ongoing process. So now just jump into some brief developer details. So our source code available on GitHub. Everything is open source, and our APIs, our Dockstore's API is served via Swagger. You can find it at these links. I'll go into more details. So basically, Dockstore implements a terse API for launching tools and workflows into the external analysis environment. So what the GA4GH is basically the Global Alliance for Genomics and Health, and terse is the tool registry API standard for listing and describing tools for exchanging, indexing, and searching. So this is basically goes on to the interoperability aspect for not only Dockstore to implement a registry of tools and workflows, but for other repositories. For example, Biocontainers is now implementing a terse standard so that there can be interoperability between registry providers and execution and how execution environments will then grab the tools and workflows from those registry providers. So right now, the latest 1.0 is the unchanging release of the terse standard. Currently, we're working on the 2.0 release, and that's under development. You can learn more about what is actually how those APIs are described and configured at the GitHub site for terse. So a little bit more about diving into that is, so here we have how Terra actually implements terse, uses terse to import workflows from Dockstore. So basically what happens when you click the launch with Terra button you're redirected to the Terra page, and you need to authenticate to get into your workspaces, etc. But then you are then, what happens behind the scenes is when you, from the Terra redirect, Terra will actually call the Terse APIs, Terse API available on the Dockstore API. So this is the implementation of Terse available on Dockstore Swagger to grab the content from Dockstore in a standardized format so that it can be parsed and distributed to the workspace environment. For 7 Bridges, it's a similar case. When you click the Launch with CGC, you'll also be redirected to the 7 Bridges portal, where they will then call the Terse implementation on the Dockstore API to grab the descriptors, containers, etc., and import that into the workspace environments available there. And so, let's see how much time. I'm running low on time right now, but that's pretty much the rest of my presentation. We've got tons of documentation, tutorials for how to implement and create content on Dockstore. And yeah, so I think we'll be creating one of those breakout rooms for if anyone has other questions. So next release, which we're happening in a couple months, is a 1.9.0 release, which will include workflow registration via GitHub Apps, the first phase of Galaxy support. So in addition to CWL, WDL, and Nextflow, Galaxy will be kind of our next workflow language. We're working on how to launch that into supported environments as well. And always the continuing improvements towards performance, security, and usability. We'll be trying to transition more completely to the version 2.0 of Terse, and trying to move the platforms that we partner with to that version of Terse as well. So, and if you want to see more about what we have planned, link the roadmap here for our general goals of 2020. All right. Thank you, everybody.
Awesome. Thank you so much, Louise. As Louise mentioned, she'll be available for one of the virtual Q&As. Thanks in advance for your participation.